Okay, so good afternoon once again. I'm just sharing the screen. Wait for a while. Not responding. Yes, meanwhile, all of you can write your numbers, 4-digit numbers in the chat box. Okay. This is a bit slow today. Just wait. Yeah. All of you can see this?
Yes, sir.
All right. So we are starting with your session number 15. And you know that we have completed multiplexers, right? So the major thing about multiplexer is it may have any number of inputs, but the output is always one, right? So that was about multiplexers. Now, just can someone tell me that when we have learned multiplexers, what is the number of inputs we have taken so far? How many input and how many output? If someone can give me the example.
2 to the power n, sir.
Very good, yeah. Do so. So that is 2 to the power n, and the number of output you get is how much?
1, sir.
Only one, yeah. So, yeah, you have any questions related to multiplexer? I think we have done enough practice on it. Okay. We will start with registers now. So this is our today's topic. See, I told you last time also that there are certain basic circuits which are essential to understand this subject. So one is multiplexer, another is registers, and the third, that is counters. Okay, so today you are going to learn again one more very important topic, that is registers. Okay, and we will see there are some categories like shift left and shift right kind of registers. Okay, so what are the shifting functions that we are going to learn? That is your today's learning. And next class we will start with the counters. All right, so here we go. This is an example of what is a register and how to use a register. Okay, so first thing, you know, there is one byte. Usually we do everything in terms of bytes in computers, right? You got 8 bits, one group of 8 bit is formed, which is a single byte. But sometimes we use a nibble, right? We use a word in form of, the size of word is in form of nibble. So what is nibble? Maybe I think some of you might have gone through this particular term, nibble, right? So half byte, that is 4 bits, equal to 1 nibble. So just have a difference between these two. How many bits, how many bytes, how many nibbles? I can ask you some questions in your maybe MCQ or short questions. Okay, so that is clear. One byte is formed by using 2 nibbles, right? So 4 plus 4, 2 groups of nibbles makes a single byte. So this is how we identify a register. Okay, when you are given a register, it means you need to assume that there are 4 bits inside it, not 8. Okay, just forget about 8. Right now we will not talk about bytes. Okay, so this is the first thing about registers, as it is mentioned here. One register is 2 nibbles, single byte. Okay, now what is register? How do we build this? Now there is a difference between what you have done in your circuits, that is flip-flop, and what you are doing in register. This is practical implementation, how you do it when you save the data. But flip-flop is just a circuit. When you use this circuit to save your data, right, you call it as registers. Is that clear? Let me go to the group and let me see. Yeah. So far all okay, everyone? Are you all with me?
Yes, sir.
Okay. Only Buso? What others? Aditya Raj,
Yes,
Prince,
sir.
Darshan, Jimmy, Michael, Dawa user.
Yes, sir.
Yeah, you got the point. What I've said starting. We are discussing registers. Okay. So you use flip-flop only, many flip-flop. You combine them, you make a register. And in that you can store some values. That is the use. Okay. So let's see the other points. What we are doing. I want to save something. See, I want to save the value, say 10 or 5. It could be anything. I don't know what is the value, right? Now, can you tell me if I have a register, it has capacity of 1 byte. Okay, 2 neighbors, that is 1 byte capacity. If you have, how many values you can store into it? Is there a limitation? As per the size, there will be a limitation, right? You all agree with that?
Yes, sir.
Yes, sir.
So, how many numbers or characters or values we can store into one register? If I ask a question, how many values I can store? One register has a single byte, right? So in 1 byte, how many values I can store? A, B, C, D. Characters I can store
2.
26 characters. Yeah, whoso? Yes. Only two values. I'm talking about 1 byte. Okay, it is
I
not
was just
single bit,
guessing, sir.
it is byte. So when you say byte, means you have 1 8 times 1, right? So it becomes 2 to the power 8. These many values you can have. So you can have characters from maybe A to Z, right? You have your local language, you can use those characters. Right? You can use 0 to 9. You can use special characters like full stop, comma, semicolon, and so on. Right? So you got enough space. 1 byte is more than enough for us. Okay. So a register, it has got n number of bits. We don't know what is n. Usually, I've given the size here. Okay, 1 byte. But maybe sometimes you say, okay, I want to go for a larger capacity. You can do that. Okay, you can have 16 bit, you can have 32, you can have 64. But again, I will not say that you can use 60 bits or 100 bit. Is it possible? Anybody? If I say I have got a register, if someone is telling you, I have saved a register which contains 100 bits, then you please don't believe him or her. Why? Reason?
Uh, because the
Yeah.
resistor is made up of nibbles, not bits. I don't know.
No. See, nibbles is just a group of 4 bits only. But when you say that it is 2 to the power, I told you earlier also, right? It is 2 to the power. So what you do is you have capacity of 2 values, you can have 4 values, 8 values, always in the multiple of 2. So that's why it is either 64 or 128, right? There is no number between 64 and 128 over here. You got it? So that is the reason. You can't say that I have 80 characters capacity or 100 characters. Either it is 64 or it is 128. Okay. All right.
Yes,
So,
sir.
you know, so there is n bit register as a group of n flip flop. If I have 5 bits, I need 5 flip flop. If I have 8 bit, I need 8 flip flop, right? So what is bit size you want? That many flip flop we will use, and we will create one space where your values are stored. This special place we call it as register. Okay. Now you may have combinational gate. How I'm going to use the combination for this, I will show you in the next coming slides. Okay, so how the register is being prepared, we will see that it is an example of combinational circuit. Okay, then flip-flop is going to hold your binary data. Okay, how does it hold? How to group the 4 bits register? We use D flip-flop, we use a clock, and we use clear for the input. Right? You want to set or reset. For that you use a clear bit. How to do this? Okay, let's go to the example here. Just have a look at this one. This is an example of a register. Whenever you see, remember one thing. When you see D flip-flop, it means it is a register. Okay. So how many bits are there? One bit per circuit. Okay, this is one block diagram of a D flip-flop. I don't need to teach you this one. This you have already done so far, right? So one D flip-flop, second, third, and fourth. Why four? Why not eight? Why not three? Why not 10? Why it is four? Because just now I told you.
2 to the power n, sir.
Yes, that is one thing. And second thing, it is nibble. One nibble is 4 bits. I want to store
It
4
never
bits.
too many
So I
balls.
am going to use, yeah, that's why, correct. So that's why we are going to use 4 bits, not because 2 to the power, of course. So now you see how we create the circuit of a register. Okay, all right, let me tell you one thing. If I say I want to store some values 2 to the power 4, what is 2 to the power 4? 2 to the power 4, please.
16.
16, right? So if I have some values from ranging from 0 to 15, some numbers are there which I want to store from 0 to 15, I will use this circuit. Okay, this circuit has a capacity to store the value from 0 to 15. Okay, so that is what is the purpose. You keep on increasing the number of flip-flop, you will get more and more capacity. Okay, so what you do in register, transfer of new data, that is one thing. See, I have value here I0, so it is copied here, that is A0. Here also same value is copied. Last time you have seen multiplexer, right? So what's the difference? Here you have only 4 bits in input, right? There you have got select. Here you don't have to select anything. The same input goes as the output. Okay, so try to look at this. But yes, you will find one thing extra here. This one at the center, all the inputs, right? All the flip-flop at the center are connected through a special line called clear. What is clear? This is like a switch, switch it on, switch it off, right? So what clear is going to do? When I say clear, make everything 0, 0, 0, 0, right? Just like reset. Mostly you have everywhere, most of the electronic circuits, you have a clear button or reset button. So everything becomes 0, right? So externally it is provided to the user. You want to make everything 0, you start the circuit from the scratch. So that's why we give this clear button. Okay, this is extra feature. But what you need to remember, more important part is this. You have clock, obviously. Without clock, you cannot switch on the circuit will not work, right? Once the clock is on, then only the input is copied. Okay, so 4 input, 4 output, in between flip flop. You have clock and you have clear. This is the 4-bit or 1 nibble. You can also say 1 nibble register circuit. Is this clear to all? You can make it. Yes, just go through it. It's not at all difficult, pretty easy. Rather, I should say register is the easiest one. Okay, so 1 nibble register is the circuit that I am showing you. Now we will move to shifting of registers, where we use shifting. Before we proceed to shifting, let us do one thing. We need to have a small practice exercise as usual what we are doing. So all of you please keep your pen and paper ready, and I am showing you the diagram. Try to remember this diagram. I'll give you 2 minutes time and then we can discuss. You have to show a 1 nibble register circuit to me. Okay, switch on your camera and show it to me. All are ready? Keep your pen and paper ready and remember all the details of this circuit. Fine. Okay, so now I am waiting. You should have taken screenshot maybe. Okay, I'm giving you 2 minutes time. All of you, please type your ID number. First thing is you type your ID number into the chat box for the attendance purpose. Those who have already typed, that's okay. Those who forgot, please do it. And then you write PNP. You have pen and paper ready? If it is so, please write PNP so that I come to know that you all are ready. I wish everyone should be ready for this. Okay. You should have such practice. Yeah, that's good. Michael, Jimmy, only 2%. Everyone else, please keep the things ready. Bring it with you. Yeah. I am going to show you the diagram one more time. Have a look. Maybe I'll give you 1 minute time, not more than that. Okay. I'm giving 1 minute. Go through this, please. Then everyone has to show me. I will speak up the number and that person has to show me. Yes, it's very easy. Yeah. And let me know who is ready with the diagram. Is it done? You could have done 2 times. Given the time to you. Yes, guys, please. I can see Angela. Angela, are you ready with the diagram, please? Angela, are you there? Yeah. Angela, you're not listening. What happened? I am waiting for your answer, Angela. Because you have written here PNP.
Oh, sir.
Yes. Are you ready?
Yes,
Yeah,
sir.
yeah. Please switch on your camera.
Yes.
Yes, please. Just switch on your camera. Sorry, any
I
problem?
am in the activity, sir.
Angela, did you remember the circuit? Or maybe we can move to someone else. Vivek Bhatti. Can you do that, Vivek?
Sir, I am
You're
doing.
doing? Just show whatever you have done. Just show it, please.
Yes.
Even though it is partial, no problem. Just I want to have a
Yes,
look.
sir.
Angela is also ready.
Yes, sir. One.
He has network issue. Yeah, I'm waiting for you. Yes, Vivek. All set? Make it quick, please, dear. Vivek?
Hello. Yes, sir.
Yeah.
Sir. Doing, sir.
Show me the camera. Switch it on.
Okay.
Yeah. Yes.
Little bit.
Only one. You have started only one.
Yes, sir. I'm
Still on
the
working.
book. I.
Okay, okay. All right, let the people finish. I will show it one more time. Okay, just
Sir,
have a
I'm
look.
done.
If anyone is already done, then we can. Otherwise, we don't want to waste the time. Michael is already done. Very good. Okay, then I'll just share it. Michael, please. Jimmy is also done. Yeah, Michael, can you share it? Or shall I tell Jimmy to share? Shyam is also done. Okay, let's see who is sharing it first. Whosoever puts on the camera first, I will check from that. Make it quickly. Yeah, Jimmy is ready. Okay, good. Yes, Jimmy. Show the diagram, please. Yeah, here we go with a red color diagram done by Jimmy. Yes, very good. You got 4D flip-flop, and this circle you put it for the clear at the end, below bottom, right? You have clock signal and you have 4 input, 4 output. Perfect. Very nice, Jimmy. Thank you. All right. So this is not difficult at all. Let's continue with the two categories. So this is the first part that is over. A register looks like this. You can switch off your camera, Jimmy, now, and mute yourself, please. Jimmy. I can see some noise coming up. Rashesh, yeah, yours is also very good. Okay, okay, noted. There is some noise coming up. Let me check. Is anybody unmuted? No. Okay. So now there is one more category. This is not just the register, but we are using usually registers for the shifting purpose. You are doing some operation, right? They're like multiplication and division. So for that, we use a shifting of registers. Now, what is shifting of registers and how it is carried out? So let's take example here. Look at this diagram. You will notice you have D flip-flop 4, you have a clock signal also, and you have input and output also. But they are in series. Rather than drawing it vertically, here I have drawn horizontally. So what happens here is, you just see here. I have input here, then whatever is the output becomes the input for the second circuit, right? And this logic continues 4 times. And at the end, I generate the output. Of course, we give the clock pulse. We don't give the clear button here. No need for clear. Okay, because this is a bitwise shifting. This is known as a shift register. Now, why we call it shift register? Let me tell you. When I have initially, let us assume you have values 0, 0, 0, 0. All the values are 0, right? Now, when I put 1, right, 1, what happens? 1 is passed here. It becomes 1 here. Remaining value is 0. Then when I put again one more 1, so this 1 goes inside. So here it is 1, 1, 0, 0. So this way, it keeps on cycling the value. So that is the reason we call it as a shift register. You can shift on the right side, you can shift on the left side. So this is how the registers will work. This is the task of a register. Now, when I am showing you this type of functioning, let me also tell you what is the meaning. I just put it in the notepad so that you can understand what is happening internally. Just give me a moment. I am not disclosing what is the use of shift register. Angela, initially you had the issue, but okay, you have created it. That's very good. You can just send me later on. That's fine. I will just verify it. Okay, you can send it in WhatsApp also. Angela, well done. Okay. So what is use of a shift register is for the shifting purpose. Now how the shift register will work, let me tell you. You have seen the diagram which comprises of 1, 2, 3 and 4. I will use only 4, always 4, because it is 4 bits. So 4 bits means what? Or you can say 1 nibble. Okay, so since we are measuring in nibble, I'm using a group of 4 bits. When I use group of 4 bits, I use 4 different circuits, that is D flip-flop. Now see what happens. Here, I have a number 0, 0, 0, 0. Okay. Now, if I pass 1, just if I pass 1 here, what is going to happen here? It becomes 1, 0, 0, 0. You all agree with this? How it is done?
Yes, sir.
So if I write 1 again, what will happen? What will be the new value? Can you please try? See, this is
1100.
and I push 1 here. It is pushing. All of you know what is pushing and pulling, right? So when you push the value here, this becomes 1, but I have a capacity of only 4. So this 0, it is removed. It goes in the air. Okay, it goes outside. So it is, we call it as 0 value. It is discarded. Okay, because we don't have extra capacity in a circuit, so we just discard the value 0. This way it will go. Is it clear? Now when I say again 1, I put 1. So what it will become? Yes,
One
please.
one one zero.
1
It becomes 1 1 1 0. Again 0 is discarded. Clear? So this is very clear, just like playing game. But you have to understand. If you, unless and until you don't understand the concept, there is no meaning. Okay, so that's why step by step I'm showing you. What is discarded here? Now I give 0. Now every time, no need for giving 1. I may give 0 also. So what it will become here? Now you tell.
0111.
Very good. Perfect. In this case, your value of 1 is discarded. Your last value gets discarded. This way, whatever value you want, you keep on passing. Ultimately, you know what happens? You just see here. If I pass 1, 1, 1, and 1 4 times, it becomes 1, 1, 1, 1. Right? So this way, whatever you are passing, it keeps on changing the values. So this is known as shifting on the right side. Okay, pushing from the left and shifting on the right side. So this type of circuit, it is useful, very much useful. Now I'm going to show you the magic here. Why we say that shifting is required. This is example of 4-bit shift register. Okay, where do we use this? Let me show you where we are using shift registers. I will show with a proof before moving to shift left and right. Okay, if I have the number like this 1010, and if I say that shift left, what it will become? Can you tell me? If I have number 1010 and I have to shift, or rather push on the left side, what it becomes? Till now what we were doing is right side. Okay, when I shift on right, it becomes what? 0101. Did you get this? What I am doing?
Yes, sir.
I push the value from here. Okay, so this is removed, this value is gone, and here I push, so nothing is there, so it is 0, so it becomes 0101. You all agree with this? If I shift
Yes,
on
sir.
right, similarly, if I have the same number, say 1010, if I shift on left, what it will become?
0100.
0. Shift on left side, right? So see, 1010 is already there, and I'm shifting on left side, right? One more time like this, so it becomes 0100. Got it? Now let us see.
Yes, sir.
See if this is clear to you. I'm just pushing it. Okay. Let me confirm the whole class, not only one or two. Everybody understood this? How I'm shifting on left and how I'm shifting on right? Or someone is having any doubt?
Yes, yes.
Sorry, sir. Hello.
Yeah, Michael.
Hello.
Shall I explain again?
Yes, try to explain again on the shift to the left
Okay.
side.
See, when I say shift on the right side, it means I push here. I push like this. Okay. So when I push, what it becomes? 101. this number is outside, you just see that this is the capacity. Okay, capacity is only 4 bits, right? Just hold on for a while, please. Okay, yeah. So I'll repeat that. What I'm saying is, when I have the capacity of 4 bits, right? This is 1, 2, 3, 4. I shift on right side. What is here? Nothing is there. You have blank here. Okay, Michael? So I put 0. And this value, whatever it is, 0 or 1, but it's already gone, right? So I remove that. So that's why it becomes 0, 1, 0, 1. Now that is clear. When I am shifting on left side, I will push like this. From here I will push. So what happens? Let's see, it goes like this. Okay. Here nothing is there, so it is 0. The remaining numbers as it is, and this is outside, so it's removed. So that's why it is what? 0, 1, 0, 0. You see here, that's why I have written here 0, 1, 0, 0 or 1, 0, 1, 0. Now is it clear?
Yes, sir.
Yeah, okay, that's good. Okay. Now, I want the answer. Now you see the magic. You will appreciate that, yes, this is how the register shifting is done. When you do any register shifting, the CPU is performing actually some operation. Arithmetic operation is performed automatically. How? Let us see. What is this number? Can you tell me? 1010 means which decimal value it is? 1010. What is the decimal value? Yes.
7.
1010 is 7? No,
10, sir.
it's 10. Right? 8 plus 2, so that is 10. See, we do like this. You remember the formula? 8, 4, 2, 1. So this is 8 plus 2, so that is 10. Right? It is 10, no? Now you tell me, if I shift the value on the right side, it becomes what it becomes? Tell me. What is 0101? Again, please use
5,
8
sir.
to 1. It is what value? Yes? Someone say it.
5, sir.
5. And when you do the shift on left side, what is this value?
4.
This is 4, right? So what happens if you have 10? Okay, if you have got 10, it becomes 5. If you have got, say for example, let me take another example. You forget about shift left right now. Let's concentrate on shift right only. We will do some exercise so that it is clear to you. If I have 1110 and if I shift on right side, what value I will get, Michael? Just push this like this on the right side. See, I think this is easy. You can see here 8421 is already written, ready made. Okay, I
Yes,
get
sir.
what I am getting now. You can
It's
see
gonna
it's
be
very
0, 1,
111, right? Okay, so what is this value? 1110. What is this value? Please tell me. 1110. That is how
7,
much? No,
7.
no. It's not 0111. It is. Let me shift. Now tell. What is this value? What is this value?
14.
14, yeah? Very good.
14.
When there is 14, it becomes what? 0111 is what?
7.
Value is 7. Now you see, now all of you please concentrate. If I have 14, I got 7. I have taken one example just now. I use 10. What I get? If I
5.
use 10, I get 5. If I use 14, I get 7. Now you tell me, if I use 16, what I will get? 8
8.
items.
8.
8.
Good answer. See, this is intelligent answer. If I have say 8, what will I get?
4.
4.
4. Every time what I'm getting when I shift right, can I use like
Half of
this? Half of a number, is it correct? Yes or no?
Yes.
You want to
yes.
do practice, you can practice and double check yourself. It is 100% guarantee. Okay, whenever you shift right, you are going to get half of a given number. So it means what you are doing, this is known as which process? Division. This is arithmetic operation division. Yes, yes or no?
Yes, sir.
Yes, sir.
Perform this operation when in C program you are writing like this divide. Okay, so when you do divide, actually what it is doing, it is going inside the shift right circuit and it will perform all the operation and give you the result. This is how practically it happens. Okay, now very simple common sense question to the whole class. If I use shift right, I get half of a number. If I use shift left, what I will get? Yes, you all agree? So it is nothing
Yes,
but
sir.
multiplication. You use this symbol, star symbol in your programming, right? So it means you are shifting to left. Okay, you'll get the double of a given number. So what it means, if I have 7, let's take example again. If I have 7, so there is 0, 1, 1, 1, that is 7. So what I should get if I shift on left side, I should get 14.
14.
14.
14.
So let's do it reverse. I should get 14. So what is the value of 14 in binary? All of you are able to see the screen, right? Notepad?
It's gonna be 110.
It will be what?
1110.
10, sir.
1, 1,
1110.
1110.
1, 1, 1, 0, right? So now just see here, you just see it is correct or not. I am shifting from this side. It means I remove this and add 1, 0 this side. Okay, so I'm shifting from left. So left means double and right means half. So this way you can keep on doing the transaction. Okay, so you can use this type of operations. Multiplication and division operators can be possible by using the shift register. So this is the use, actual practical use I am showing you of this type of circuit. Okay, now let's see. What is the table structure for it? Just a minute. Yeah. So this is a function table. What it says, again, you have two possibilities, S1, S0. If both are 0, you are not doing any operation. Okay, I don't want to do anything. So that is called no change. If I use 0 and 1, it means shift right side. Okay, maybe you can say up and down also. So shift right. So the value goes down. Okay, shift left. And both are parallel. Both values are there. It means, see, this is a special condition which is we are difficult to handle, right? So this is not possible actually. So this is one error which will appear if you use the shift registers. Okay, so there are 4 conditions: either no change, shift left, shift right, and parallel load. So yeah, this is the explanation of it. How you are using the D flip-flop and how the values are shifted from one to another. Now you just see here, okay, counters. Now counter circuit is different. When we will use counters, that is for the counting purpose, that is frequency counting. Okay, see, yeah, let's Understand this part now. So this is what is all about the shifting process. Now, if I ask you a question from this, that you have to use, this is a shift register 4-bit, right? But this is shift left or shift right. Can you tell me this is a shift left register or right register? I input the value from left side and get the output on right side. So this is which side shifting?
Right side.
Right side. Yes, you agree? Very good. Now I may ask a question that draw the model which shows 4-bit left shift register. What you will do? 4-bit shift register for shifting from the left side. Instead of like this, you have to draw from left. So what change you will require in this? Can you tell me?
The serial input will be at the right and the serial output will be at the left.
Only. Very good. Very nice. See, it's a simple difference. I write here serial input. I start input from here and I write serial output on this side. Okay. So that is shift. So ultimately say this is input and output going from one place to another. Very simple. Whether you look from front or back doesn't matter. So actually this is one and the same. You look from back side. See, you just imagine there is a mirror. Okay. Someone is looking from here, front. So its input comes first, output goes at the end. But if someone is standing on the back of this, what will happen? You will see the output on this side, left side, and input on right side. Okay, circuit is same only. So just for your understanding, shifting is done for the by the same circuit. Okay, only the logic will change. Now the problem is, yes, we have one issue, that is bidirectional shift register is there with parallel load. Whenever there is a parallel load, this is a special condition which we cannot handle. So to take advantage of this, there is another circuit which is suggested, which we call it as a counter. Okay, but before I move to that, I want you people to have one more practice, so that after that you can finish off with the shifting. Okay, just have a look at this circuit, and I want someone, rather most of you, to draw the circuit and show it to me. Okay, it's again even more simple than the previous one. 4D flip-flop, and you have clock, one serial input, one serial output. That's it. Dipesh, you are joining now. Dipesh, the class is almost over and you are joining now. At least within first 1 or 2 minutes you need to join. Otherwise there is no meaning in coming to the class. Yes, so who is ready with pen and paper? Angela, let us do one thing. Let's see your previous diagram if you are ready. Yes, Angela.
Okay.
Possible? Yeah. Okay, good. Yes, please, I am waiting for you, Angela. And meanwhile, guys, please start drawing the shift register diagram.
I've switched on my camera. Is it visible?
Yes. Yeah. For flip-flop, I can see it is little blurry. Yeah. You have drawn perfectly. Yes. Only for the clock, you forget to mention for clear button. For clear button, you forgot to mention CLEAR
Okay.
at the bottom. Okay. Everything else is correct. Perfect.
Okay.
Okay. Yeah. Thank you. Now I will show you. Let us example of how the shifting is done. So for shifting, you do one thing: convert, or rather divide the numbers. I will say that you have number like 14, you have 12, you have 6, and you have 5. And similarly, multiply the numbers. Let us do one short exercise here. You have to multiply the numbers, that is 4, then 6, and 9. These three numbers. Okay, what you have to do? You have to show the binary form. And okay, first you tell me, for division we use what? Shift what? Left or right? If I want to divide, we shift left or right? Please answer.
Right.
Right.
sir.
Right.
Right.
It's
Right.
right. And shift multiply means shift left. Now what you have to do? I will show you one example. Number 1, that is for 14. I will show you. The value of 14 is, what's the value of 14?
1110, sir.
1110. Now when I shift on the right side, it becomes 0111. So that is 7. Right? So I'm getting the correct answer. It means yes, I'm getting the correct answer. Try for 12 and tell me what you are getting. Same way for 6. Show me the result. Here shift left means you use 4. 4, what is the value of 4? That is 10. Right? Now when I shift on this side, so I put one more 0 on the left side, on right side. Okay, so 0, then 0, and then 1. So this becomes, what is this value? 100
8, sir.
is 8. So it becomes double, right? So multiply, it becomes double. So for 4 it becomes 8. It's correct. Try for 6, and also you try for 9. All of you, please finish this and show it to me. You can do it step by step. I want to see first who has done about 12 and 6. This I have already done for you. Okay. Let me see for 12 and 6 who is able to do. For 6 and 9 who is able to do. There is no need for switching on camera. You can just, once it is finished, just type it in the chat box. I will be able to see it. Yes. Yes, please. Michael has started with number 6. It is 0110. Okay, that is the value of 6. Now what? 12. Okay. I want the answer also. 0110. When you shift on the right side, what it becomes? 12 is, you are right, 1100. But when you shift, what it becomes? Show me the result also. Shifting result, what it is? Yeah, Rashesh has written 60110. It becomes 0011. So that is nothing but 3. Very good. So this is how I want. What Rashesh has written, the full answer you write down. What about 6? Did anyone write? Yeah. This is for 6. Sorry. This is for 6. What about 12? Can someone try for 12? Shift it on the right side. Check the answer. Is it coming half of the original? 9 is 1001. Okay, that is written by Michael. So once you divide, what it becomes, Michael? 5 is 0010. Where is 5? Sagar, where is 5?
So what's the question again?
The question is, when you are shifting, what you get the answer? This also you should specify. This is okay. But after shift, what you get? See, you are doing 2 operations. This is divide operation for all this. And for this 3 number, I do multiply. I am doing 2 operations here. Okay, you are showing me half part. What is other half part? Yeah. See, Sagar has written. Number 5 is 0101 here. Where is 5? There is no 5. Ah, okay, yeah. You are right. There is one more answer, 5. That is 0101. And when you shift it, it becomes 0010. That is, it becomes 4. Is it correct? How can 5 become 4? When you divide the value, what is 0010? Is it 4? It is 2, right? Yes. So when you divide 5, now you see, you come across one more magic logic of this. Try to understand. When I divide the number 5, which value? When I divide by 2, what is the correct answer actually? 5 divided by 2, what is the answer?
2.5.
2.5. We can't have 2.5, right? So that's why the
Yeah,
half part is
because
ignored and I get 2 here. So it is absolutely yes, the correct answer. This is the correct answer. Okay, so sometimes that's why I gave you this example. If you use 5, you get half value. So that is not 2.5, but it is 2. But it's correct. Okay, half value is ignored. What about this one? For 12, yeah, the case has written already. You are getting 0110 if you shift. It means what is this value? 6. Right? So this is also correct. Let's move to last three values. What about 6? When you make the 6 double, dawa, you have tried this. Okay. The value of 6 is 0110. Now I shift. When I shift on left, what I do is I just push the value 0 here in the original value. Original value is 0110 and I put one more 0. So what is this now? Tell me. Which value is this? The
12.
shares has written already 8 plus 4, so that is 12. You are getting the same 6 multiplied by 2, so it is 12. Yes, multiplication is done, so it's correct. And the last one, you have 9. Value of 9 I already given 1001. You put see 1001 and then one more 0. So what is this value? 0 on right side, that is shift left, and 0 on left side is shift right. Remember this. Please don't get confused. Okay. What is this value? Can someone tell me what is this value? You need to calculate. You want to
18,
verify.
sir.
We can do one thing. I will divide this one. You can see what is happening. You know the logic.
It's 18, sir.
Yeah. No. I'll just mention it clearly. 8421 is the logic, but still you have one more. So I write 16. So 16, 8421. So 16 plus 2. So that is 18. Okay. Now you see this 9. Double of 9 is what? 18. Okay. So yeah, this is how we are doing shifting of left and shifting of right. So that's all for the shift operators. Okay, so we are using the shift operator in this way. Actually, in your programming, you are already using it. And how you are using? So the answer is we use registers. Okay, D flip-flop register is there, which will provide with this type of solution. Okay, so that's all for today. And as I mentioned, next class we will see counter. When you use counter again in programming, in your program, you want to count how many times, 5 times, 10 times, 50 times. So if you increment, it's like increment plus one every time. Then we are using counter circuits. Okay, so in such case we will use counter circuits that we will see in the next class. So that's it. I want someone to just summarize what we have done in the class. I hope all of you have written your numbers for the attendance purpose. Yes, who can summarize? Michael, can you summarize what we have done today? Just one or two.
Yes, sir.
Yeah, please.
Uh, we talked about, we started with the registers.
Okay.
We talked about registers. We talked about left shifting registers, which is the shifting right register and shifting left
Yeah.
register.
Left and
We
right
looked at
registers. Yeah.
yes. We also talked about shifting light being in a division type of shifting, whereby the numbers, if the value is high, it comes at none lower than that. Like you split it into two.
Two
And
parts,
then
yeah.
shifting as a multiplication type of shifting. Yes, so the number goes higher. Yes.
Okay, thank
And
you,
also
Michael. Now all of you can exit. The class is over. Okay, thank you everyone. And I can see, because we have MCA class, some students of MCA have already joined. So keep joined. The numbers with series 30 keep joined. All the remaining students of BCA 1, please leave the class quickly. Okay, I'm starting another class right now. Please leave everyone. Michael, Rashesh, Angela, please leave. Okay, the class is over. 30 series, please stay till these people are gone. Maria, Rashesh, please exit. Maria and Rashesh, exit please.